like to introduce Huss from CrossFiber.
I hate being tied down to a podium. Okay, good morning again, everybody. My name is Huss Tigli. For the newcomers, I head up CrossFiber. CrossFiber makes optical switches, all optical switches. Our products are designed into equipment that are made by system integrators. So our customers are system integrators and telecom OEMs. And we're located in San Diego. So this session is going to be optical switches. And it's going to be a bit different. I really don't have a presentation per se. Optical switch applications are emerging applications in fiber to the home networks. There are a lot of studies, there are some deployments, and we're all trying to figure out what the value proposition is in various portions of the FTTH network. We're all trying to understand the requirements for switches, and we thought, together with the panel here and you, we could engage in that conversation of what really are the requirements. Should there be standards? Should the typical telecom standards apply to fiber to the home networks? And that's the spirit of this panel. You've met a cast of characters already, so I'm not going to have them reintroduce themselves. So essentially we have Sandy from FiberZone, Ray from Inlight, and Jim from Kalient Networks. You've seen this block diagram before. As we've said, Verizon has studied switching applications and other aspects of fiber to the home in detail. And you've already heard previous speakers talk about the test application using N by 1 by N or N by 1 switches. You've also heard some speakers refer to N by N switches in the central office. So just to kick off the conversation, this is really a typical test application. It could be here in the central office, or it could be either inside the cabinet, or you could send a technician to do that testing at FTTH. And this is more like a central office application where, let me step through a few times, where we're using the N by N switch either for protection of the PON or in some instances potentially for load balancing. Now, one of you, I guess the gentleman from the Light Brigade, mentioned the possibility of optical switches actually inside the FTTH. That's also being studied and proposed by several people. That application, of course, has some special challenges, not the least of which is there's usually the problem of power. How do you get power to that location? But they're interesting and exciting applications of optical switches in this network, and some of the benefits you've heard already. We as switch manufacturers are excited about the potential, but yet we do want to engage in the user community like you to make sure that we understand all your requirements. So I'm going to kick off the discussion. I made a list of some of the generic requirements for optical switching in the set of applications that we talked about. Physical size, switch matrix size, the gentleman from 3M already asked that question. What are the power requirements? What are the backup requirements? What are the optical switch performance requirements? How fast does the switch need to be? Across the applications, what are the optical loss requirements? Sometimes you can tolerate them, sometimes you cannot tolerate them. In the video application, what are the issues with return loss? And especially in the outside plant, we have some people here from Hawaii Telecom that deal with outside plant. There are some special requirements. We all know that the outside plant environment is not the same as the central office environment. And what are those special requirements? Before CrossFiber, I ran the telecom business of Raychem, and Raychem made a lot of products for outside plant. And I remember very distinctly, I was making a customer presentation just like this, and we were talking about a new product, and the customer said, "Have you tested this product for resistance to the urine of ants?" So ant urine. And at that, up to that period, I didn't even know ants urinated. So I frankly did not know the answer to that question. So there are a lot of special requirements in the outside plant. So that's what we're going to talk about. Let me, rather than going through these one by one, let me ask the audience, what's on your mind in terms of the requirements in this list? And then we'll get the panel to chip in, and we'll have a discussion.
Well, like any piece of equipment, I mean, we've covered a lot of it on that list there, but, the mean time to repair, how easy it is to fix or work, or how resilient the equipment is between failures would be something.
Okay, so one question is really reliability of optical switches. And it's a very good question. On this chart, I have some standard requirements for optical switches. These are Telcordia requirements, and all optical switch vendors need to qualify to these requirements. And some of these involve temperature cycling between very low temperatures and high temperatures. They involve shock and vibration tests. And a typical requirement for optical switches is that the lifetime needs to be, and I'll answer this and I'll ask you guys to talk about it. The lifetime needs to be greater than 10 to the 9 cycles of switching. That's one of the accepted standards. And we all need to, in our qualification testing, we all need to show evidence that we have done it. Sandy, Jim, about reliability, meantime before.
All right. Yeah, this is an incredibly important area, particularly for the major incumbent providers, anybody who's got customers out there already that they are serving and have a history with Telcordia standards and so on. We are a NEBS Level 3 compatible product. And UL certified, TUV certified, the regular regulatory regimes. But to really address the resiliency issue, we have modularized the product. We have hot swappable cards, field replaceable units, and the product itself can be grown in increments. So it's a product that has really been focused on the needs of the customer to have that field-based flexibility and ease of use. We have continued to try and push the boundaries for greater mean time between failure, and we're now at a 37-year rate. So we think we've really done a great job trying to address this, and the rest of the industry has done much of the same as well, but with their own unique solutions.
Thanks. Yeah, as Jim said, this is a core question that we're always asked. It's one of the top 3 questions. Fiber Zone, like all the others, were developed for telco environments, so we passed NEBS Level 3 and all the other acronyms. I think our approach, again, from a technology standpoint, differs a little bit in that, again, we provide a latch connection. So the connections are really not subject to failure due to any failure inside our system. So we've sort of decoupled the question of connection reliability from system reliability. The connection's always secure. course, people are still interested in mean time to repair. Obviously, if you lose something inside the switch, you want to be able to get the switch itself up and running quickly. And so we've designed ours to be able to any of the components that are subject to failure can be replaced, sort of slide in, slide out without impacting the connections that are in place. So, but I mean, the main sort of parameter that we design to is, if you lose power, internal power, external power, you lose the CPU, you lose some piece of active component inside our system, you don't lose any of the connections. And I think for fiber to the home particularly, that's the main issue is, don't lose the connection, don't lose the connection. So.
And that reliability question is really critical more critical for this application than the testing application. But we're all used to, as switch manufacturers, we're all used to making sure that the long-term reliability of the system is there because, in fact, all of our products are also slated for long-haul transport, for example. And there you're carrying, gigabits to terabits of data, and you just cannot afford to have a failure. So let's maybe talk about the matrix size. You've asked the question, what do you need for these various applications? What does N need to be? So let's separate two applications. One is the test application. The other one is the FDF application. So let me ask Troy and Ray, for the test application, what are the needs for 1 by N? What does N need to be? What can you get away with, and what would be nice to have?
Yeah.
What are typical applications?
Okay, I'll start. Yeah. Okay. In our situation, typically they'll go up to 1 by 24. They'll check 24 fibers from one RTU, or remote test unit, OTDR system. The highest we've done is 96. The disadvantage when you do a switch of that size is that depending on your trace, you have to go through, and let's say it's going to take 30 seconds, you got some resolution and so on your OTDR trace to do each trace. What's half of 96? 48? 48 minutes before you test that first fiber again. So a lot of time, so that's your trade-off. And it's not due to the switch. The switch is like, very quickly. It's the OTDR trace that's taking the time. Some people will cut that OTDR trace, the original trace, down to, so it's like 10 seconds or 15 seconds. And so it does a very quick trace. You don't have as much detail then. The system is set up, however, so that it'll do very quick traces. And then if it sees a deviation, then it changes the parameters and takes a very detailed type test so you can find your locations and so on. But that's kind of the trade-off. Our typical switch is a 1 by 24. That's very typical for us. And like I say, the maximum is 1 by 96. And we did have another customer that was going to do 1 by 96 and decided to do two 1 by 48s just to reduce that cycle time.
In the environment, and Troy, correct me if I'm wrong, Troy, is more talking about inter-office or undersea cable, which is a whole different aspect compared to PON when you're sizing it that way. And you've got a cost issue that's different in a sense. In the fiber to the home issue, cost is a big issue. I mean, is ads per, the way we look at it, what is the cost per subscriber? What is that going to be, as such? And the switch is a major component of that cost. And we typically, on the low side, would be around 150. 1 by 150 would be, or gain 150 access points. Like Troy, though, we have a cycle time. If you want to do routining, the maximum size is about 300, 450. We do a 1 minute quick test, which Troy referred to, And if we see a deviation in that particular PON, we would go back and do a 3-minute test that gives us the resolution that we need. So in order to do every line every day, again, every line means, we're doing PONs in a PON. Of course, if it's 1 by 64, we can do it quicker in a sense, but we look at it as a CO 10,000 lines. That's what we're looking at. 10,000, can we cover with one OTDR and one switch, 10,000 lines do retaining, and that's basically where we come up with the number of 300 to 450 on a 1 by 32 basis.
Troy?
I was just going to say, to summarize, although I think it made sense. So we have two different areas. I'm testing to the splitter, so that's where I get the 1 by 24, and he's testing to the Okay.
Yeah, so he's got more at the end.
Yes, he's got to test a lot higher quantity than I do.
Right.
Yeah.
Now, in the other application where the switch is sitting in the central office and it's essentially an automated patch panel, there are a lot of design choices there because really you got to decide how many FTTHs to gang up on one circuit. So given the design choices, Jim and Sandy, what are the requirements for that application in terms of switch matrix side?
I think there's no magic number from what we've seen in fiber to the home and our cross applications. So it's not like you can say this is the number. I think, our product, our core product is 180 connections, but it can scale up or down based on, it really is driven by the architecture of the FTTH network, as Huss just mentioned, or the long haul network, or whatever it is. So if you're serving, 100 FTTHs or 20 or hundreds, and in Asia you sometimes see even thousands, it really can depend. Really you're going to design your switch, the switch solution accordingly. One thing that's worth mentioning is you usually don't need for an FTTH central office application, you typically don't need full non-blocking across. If you have, again, in places like Korea or Japan where you may have thousands of splitters served from a central office location, there's really no need to have complete non-blocking between every single OLT and every single splitter. So you can design, the switching solution accordingly. The other thing to mention is that there's, it was mentioned before by the test vendors that you have the test time and the switching time, and that depending on the type of a test scheme that you want to have capable in the system, that can be impacted because it takes time to do that. In my presentation, which is coming up after the wake up coffee break. There are some interesting test solutions coming out which are integrated in with some of the central office electronics, which address some of those issues as well, so that you can not be dependent on the switch, for example. So it's you got to tell us what the deployment is, and then you can design the solution.
Yeah. So no magic size.
Yeah. I agree with everything Sandy said. A slightly different way of saying it is not that there isn't a magical number, but there are many magical numbers. There are large carriers that have cross-connect locations that have thousands of connections, data centers that have thousands of connections, and they want to be able to have an any-to-any. And then you have deployments that are a much smaller nature. It could be on order of 64 by 64 or 72 by 72. And then the test scenario is really an asymmetric application rather than a symmetrical application from a switching perspective. And each of these presents a unique challenge, and you can build your architecture depending on your technology to try and favor one size or the other. But no one of these markets has dominated, or magical numbers has dominated so far. So we've had to be very flexible. And so we have a product that will go from an 8 by 8 up to a 320 by 320. But it is a symmetrically based switch. If you want to use it in an asymmetrical application, there's a certain amount of ports on one side or the other that don't get used. But that'll be a future design.
So I guess from your point of view, you really don't need to worry about the switch size. We all make switches of flexible sizes, all the way from 1 by a very large number to a very large number, any to any. This non-blocking thing that that Sandy talked about is, do you really want to connect all ports to all other ports, or is any to many good enough for your applications? And in some cases it is. When you think about optical switching, what do you guys worry about? What are these, on this list of requirements, what's the one that raises questions in your mind? Any one of these?
You are defeating the purpose of local PON passive network by putting concept switch and applying power in the edge. Because all the outage.
That's the deal with this. That's one of the arguments for this is the fact that if we start putting ROADMs or any type of power out of the FTTH, it's now no longer a passive optical network system.
Right.
Then we have to worry about conditioning and power and backup power and whole nine yards. And that's why I was kind of wondering if eventually the switching system, we talk about eventually doing a dual redundant system out to the customer. And eventually
Right.
we might be able to place a switch out to the customer, a small 1x2 redirect
Mhm,
at the
mhm.
customer
Yep.
level, because the
Yep.
power would be there and it would be controlled, and you'd have that situation covered.
Yep. It's possible that the architecture does go that way. People who've studied switch applications in this entire network have come to the conclusion that out of all the applications, the switch in the FTTH is probably one of the last deployments that people will think about, and your idea might be sooner than that. I think most people in thinking about design are really concentrating on the test application and the COFDF application for exactly the reasons that you talked about. I think that's the overall conclusion of the industry that's studied this in depth. Okay.
Well, I have another question.
Sure. Go ahead, please.
It's the kind of a thing where it's the redundancy of the system. Hopefully you have somebody sitting there that hopefully the OTDR doesn't go down for some obvious reason. Is there an alarm to call that out? Obviously there should be, just in case something goes horribly wrong with the whole entire system and your OTDR has a backup.
Redundancy of redundancies. Ray, Troy,
Yeah, that's
OTDR.
obviously a hardware redundancy on the OTDR. The answer is we haven't had that asked too often, and the main issue is it adds costs.
Yeah.
And again, we're looking at some fairly low cost per subscriber. I mean, that's the big issue that we have. The issue is, can it be done easily? You have even as simple as a 2x-N where you have a backup. But we also have an application which has more to do with the construction side, where we have a second port on. It's a 2x-N, and it's a optical power. So you want to send optical power with somebody with a power meter out in the field does some measurement, and then information is passed back and forth through the optical layer to verify that. So we've looked at that, and basically that's what you do. I mean, if we're doing routing and we're getting some screwy results, our software says, hey, there's something wrong here, and where is that going on? What we have backup for in the system approach is that the actual database is at the CO as well as at a NOC center. I'm talking where you have multiple COs. Whereas if you do lose a CPU, for example, you go ahead and replace it and then download it. So we have that capability. So from that redundancy, yes, but it's not immediate, and especially when we're dealing that from a testing point of view, we're not service affecting. I mean, wavelength, the hardware. So yes, it's inconvenient. Yes, we have some ability to verify that our equipment's working, but the redundancy, it depends what you want to pay for it. And this gets very, very critical because we're not using a $500 OTDR, I'll tell you right now. No way near that. So this is not an inexpensive application. That's why we want to spread it among as many customers as possible, obviously, keep that cost down.
And I'll just, our product has been on the market since 1994, and we've actually got some test units that have been working 24/7 since that time, and they're still running, to this day. Obviously, would love to sell multiple units for people to have them there as spares. Typically, what they do, there is some diagnostics in the software, like comm alarms. They'll keep track of communication alarms if there's a break. Even though, the system's running, you'll get a report saying the communication was disrupted between the server and the RTU, this many times in the past week. It's kind of a rare thing, and it's not really critical, too critical unless an alarm happened at that point. And that's not typically the equipment. If the OTDR has a failure, you'll get an alarm. It'll be mod serve dead or something like that. There'll be an alarm, and you'll get that report. Typically, our customers have one spare unit, and they just have that, and they rotate it through if a unit has to be serviced. But it doesn't happen that often. And even we've got one customer that has 2 spares, and they have about 70 RTUs. And so they just keep those as spares just in case, because the system is critical. They see it as critical for maintenance, but obviously it's not service affecting. If a test device goes out, they'll see the alarm that the test unit isn't working. They'll go out there, swap it out, send it in. But obviously their network is still working.
Another question as far as return loss is concerned.
Yep.
Return loss, I would think would be more of an installation problem, so other than just basically something to be monitored, unless somebody goes out there and physically messes with the network in some way, shape, or form, like i.e. contamination from, not cleaning the connector properly or whatever. So, is this really a big issue?
So the question is return loss really a big issue if you have clean connectors after the installation? So from an optical switch manufacturer point of view, we need to worry about it because we need to worry about the return loss inside our switch. That I just put it up there to make sure that we don't create return losses that are not acceptable to the network, because you won't see what's in our switch. But all of us will tell you that there is no return loss issue. It's just, on the list to be complete. Any questions?
What would be the temperature concern? Is that the laser affecting the temperature?
No, it's really the concern is that the switch needs to be reliable over temperature excursions up and at lower temperatures. So when we do our qualification, we need to test the operation of the switch at low temperatures, for example, down to minus 10 C, and then higher operating temperatures. If the switch is sitting in a rack, even if it's in a temperature-controlled central office, the rack temperature could get reasonably hot, and we need to design our switches to make sure that the performance is good across temperature.
Well, plus if you lose environmental controls within the central office, you may have to operate within extreme parameters.
Exactly. But those are all covered under Telcordia, so we all have to test our switches to those requirements. Of course, if we were to make switches that sits in the cabinet, the temperature requirements could be even more rigorous. But we've already said that that's the least likely near-term application. One last question. For fiber-to-the-home applications, there are really no specific requirements for optical switches. All these are for central offices. Any thoughts in the group on whether or not, and from the panel, there should be specific requirements or standards for fiber-to-the-home? And if so, what would they be that are different from central office? Or some FTTH standard?
There, you know, some RUS requirements for how the cable's built and stuff like that. And, you know, there are some governing, you know, industry standards for that.
Not applicable to optical switches in that environment.
What about the test equipment?
So for requirements for test equipment, are there standards other than Telcordia that govern
There are
those?
some standards for test equipment, but they're typically don't cover the mechanical so much, but there are drop tests, and we're talking portables in this case. So, but there are standards. You rack mount a system in a Bell company office, you are required to do full NEBS-free compatibility. Okay. So it has to be NEBS-free compatible in a Bell operating company.
I think California has come out with a central office layout. I believe it's some sort of central office, and I don't know if you got it up there, but it's a way to set up the central office as far as its layout and so on and so forth.
Yeah, I'm not familiar with that. That might just apply to larger system-level equipment, because all of our equipment goes in a small portion of the rack. But it's possible that there's some layout requirements. Are you guys aware of layout requirements?
Just from the standpoint, as Ray mentioned, the NEBS 3 compliance, and we have to do that. And Verizon's doing this new tier approach on environmental. Any network element now has an environmental improvement component associated with it that goes into their network, and it has to show carbon reductions or reduced heat loadings and things of that nature. At this point, our equipment has not been standardized as network element equipment by any carrier. And I think that's really what we're trying to raise here. Is there a need for us to undertake standards work for specifically optical switching, so that it does get included in some of those additional areas, like tier testing and so on?
So the default position for us would be no, right?
Yeah. In order to maintain the standard of consistency for companies to be able to be competitive, as well as be able to manufacture switches, however you manufacture them, either with MEMS or mechanical movement of fiber or whatever, there has to be a certain amount of repair time or restructuring time. Either we have to be operating at a standard 50 milliseconds reswitch for a problem, or whatever the case may be. There has to be, for optical, there has to be a certain amount of probably what you're talking about as far as back reflection issues, as far as that is concerned, as far as loss across the network. There should be some sort of limit as far as that's loss across the network.
So Telcordia, as far as I'm aware, and you guys chip in, has suggestions for all those things that you talked about, switching time, etc. But it's not prescriptive. And maybe it's not so bad that it's not prescriptive, because every application is different. Sometimes you can tolerate a minute switching time. In some applications, you need to be in a millisecond range. So therefore, Telcordia doesn't tell you what the switching speed has to be, but there are some guidelines in Telcordia, right, guys? That's
yes. And we all meet the
Right.
Telcordia standards, for those types of deployments. It's whether or not there should be something unique for optical switching as it's deployed through the network. And I'm getting a sense that it's probably not that critical, as long as we comply with overall OSP requirements or overall central office requirements.
Right, that's the feedback, at least from this group.